Hello students. Today we are going to start off with a first chapter of organic chemistry for standard 12th, and that chapter is halogen derivatives of alkanes and arenes. So let's start with the very first lecture, and in this module or this lecture we are going to discuss about classification of haloalkanes. Now the very first thing, let's start with the classification of haloalkanes. They are classified into two types. First one is based upon the number of halogen atoms. How are they classified? They can be classified as monohaloalkanes, that is alkyl halides, or polyhaloalkanes. Now, talking about monohaloalkanes, let's see. Over here, I will replace one hydrogen with one halogen atom. So what I have done, मैंने एक hydrogen निकाल दिया, उसके जगह पे एक halogen introduce कर दिया. Over here, let's see. I have a compound C2H6 which is ethane. इसमें से if I am removing one hydrogen, adding one halogen, you would get a compound which is C2H5X, and this compound C2H5X would be referred as a haloalkane. So how would we define haloalkanes? It's when one hydrogen atom of an alkene is replaced by one halogen atom, the corresponding compound is referred as a monohaloalkane or a halogen derivative of alkane. So moving on further, you can understand one more thing. What is polyhaloalkanes? Let's see. Polyhaloalkanes can be further classified into dihaloalkanes, trihaloalkanes and tetrahaloalkanes. Dihalo, as the name suggests, contains two halogen atoms. So let's start off with the example. Okay, let's suppose I give you two examples. First one are these two compounds over here. Let's see first. Okay, now in these two compounds, what can you see? What is the difference? The very first difference over here is in the first compound on the extreme left hand side, over there two chlorines are attached on two different carbon atoms, and please remember these two carbon atoms are adjacent to each other. Whereas in this compound over here two halogens or two chlorines are attached again, but then they are attached on the same carbon atom. Further, moving on, these compounds would be thus referred as vicinal dihalides and geminal dihalide respectively. Vicinal कब आएगा? When you have two halogen atoms attached on two different carbon atoms, लेकिन both the carbon atoms are adjacent to each other. And geminal कब आएगा? When you have two halogens attached on the same carbon atom. Moving further, how are vicinal dihalides named? Let's see. First of all, you would have alkyl. Definitely in both the cases. In both the cases you would get dihalides. So yes, vicinal mein you would have alkyl dihalides. Geminal would be alkyl dihalides again. But then to recognize that yes, first compound is vicinal, second compound is geminal. Okay, what you would say? First one is alkaline dihalide, whereas second one is alkylidine dihalide. So pehle wale compound ka, that is vicinal, what would be the name? The name would be ethylene dihalide or alkaline dihalide. Secondly, the next name would be ethylidene dichloride or dihalide. Further, I could also name them according to the IUPAC nomenclature as 1,2-dichloroethane. The next one, geminal, would be referred as 1,1-dichloroethane. Now, moving further, what is the next important thing that we need to understand? What is the similarity over here? The similarity is that दोनों compounds में दो halogen atoms है, and if two halogen atoms are there in both the compounds, definitely these compounds would be an example of dihaloalkanes. So what we can say, dihaloalkanes can be further classified into geminal and vicinal dihalides. Next, note that geminal and vicinal dihalides are isomers of each other. And which isomers? They are positional isomers. Just check over here in the IUPAC names, you can observe the first one, that is geminal, would be having 1,1-dichloro, whereas vicinal has 1,2-dichloroethane. Okay. Further, the general formula of any dihaloalkane, whether it is geminal or whether it is vicinal, the general formula would be CnH2nX2. Let's move further. Polyhaloalkanes can be further classified as trihalides or trihaloalkanes, and next one is tetrahaloalkanes. Trihaloalkanes, it should contain three halogen atoms. So let's take an example over here. Let's suppose I have a carbon attached to 4 hydrogens, methane. मैंने क्या किया, इन 4 हाइड्रोजन में से 3 हाइड्रोजन मैंने रिप्लेस कर दिए. Again, with what? With halogen atoms. So 3 hydrogens I have removed. Instead of that, I added a halogen atom, let's say chlorine. Over here, this compound, which is CHCl3, is an example of a trihalo compound. Why is it a trihalo compound? Because you would definitely say that over here I have 3 halogen atoms within the same molecule. Next, so CHCl3 is referred as trichloromethane, or it's also referred as chloroform. Next one, the compound contains 4 halogen atoms, and whenever you have 4 halogen atoms, the compound would be referred as a tetrahaloalkane. Let's look at the example for this. Over here again we are having a carbon atom connected to 4 hydrogen atoms, and इस बार हम लोग ने चारों के चारों हाइड्रोजन रिप्लेस कर दिए. So now if you replace all the 4 hydrogens with, let's say, 4 chlorine groups, then the compound is a definite example of tetrahaloalkane. Similarly, CCl4, what is the name of the compound? The name of the compound is carbon tetrachloride or tetrachloromethane. Please remember one more point over here which could come in very handy, and the point is carbon tetrachloride is often used as a solvent, or we could say as an organic non-polar solvent. Okay, इसको याद रखना. Fine, let's go further. Now, classification based on nature of alkyl groups. हम लोग ने स्टार्टिंग में ये बोला था कि classification is based on 2 different things. First one is the number of halogen atoms. Second one is based on the nature of alkyl groups. Let's see this. Over here, I have 3 carbon atoms for you, and if you notice, all the 3 carbon atoms are attached to a halogen atom. So definitely all the 3 compounds are haloalkanes. But then, देखते आगे. In the first compound, I have this carbon atom which is attached to one alkyl group. Let's see. आगे देखते हैं. Now, in the first compound, I have a carbon atom which is attached to only one alkyl group. Second में it's attached to 2 alkyl groups, and the third compound it is attached to 3 alkyl groups. Now, if you notice, the first compound, carbon is connected directly to only one carbon atom, which is one alkyl group. Therefore, this type of compound would be referred as primary. Second, the second carbon atom in the second compound is connected to 2 alkyl groups, तो ये secondary हो जाएगा. And the third one over here, it's connected to 3 alkyl groups. So what we can say, on the basis of nature of alkyl groups, you can classify your haloalkanes into primary, secondary and tertiary alkyl halides. Let's see. Over here, if you notice, primary alkyl halide would always have a formula of CH2X. तो अगर identify करना है whether you have a primary alkyl halide or a secondary alkyl halide, you should have a formula of CH2X. Secondary के लिए you should have CHX, and tertiary के लिए you should have CX. Let's move further. So what we can say, on the basis of alkyl groups, you would get primary alkyl halide when X is attached to a carbon which is primary, therefore primary alkyl halide. If X is attached to a carbon which is secondary, secondary alkyl halide. And if X is attached to a carbon which is tertiary, it would be a tertiary alkyl halide. So when you talk about classification, classification can be done on 2 bases, either on the number of halogen atoms or on the basis of alkyl group. Number of halogen atoms के ऊपर अगर classify करना है तो it would be mono, di, tri and tetra. Further, अगर nature of alkyl groups के ऊपर classify करना है, then it could be primary, secondary, tertiary. That's all. So with this, we finished the classification of haloalkanes. Let's meet up in the next module with further alkyl groups. Till then, thank you students and happy learning.